Thanks, Matt. So just a little bit of a precursor to this. For those of you that are familiar with MEV Boost, MEV Boost is a validator proxy software that validators are optionally activating. And at the moment, it is serving one kind of application for validators. So what it is doing is that it is outsourcing who gets to extend the chain. So rather than the validator extending the chain, they're saying, oh, we'll outsource the block space for somebody else to do it in exchange for some kind of a fee. And maybe you have like a minimum fee for that, or maybe you have, you just will take a block from outside. You don't want to build blocks, you just want to outsource it elsewhere. That is one application. And that one application works in a specific way. So that has a protocol for interacting with relayers, accepting bids, and all that sort of thing. Completely 100% off-chain. Cool. So how does MEV Plus relate to that? What is MEV Plus? So the similarities with MEV Plus, they start at the proxy software level. So it's something you plug into your validator client. But it's about much more than just block building. So block building is an application that you can add on. That's not a problem. You can still do that and make that revenue stream. But what about other revenue streams? You know, for validators. You know, expanding sort of that revenues for the same cost base. Where did the revenue come from? You know, it can be off chain. It can be on chain. It really doesn't matter when it comes to MEV Plus. So MEV Plus is about expanding and creating a marketplace for allowing validators to participate in services in sort of an automated fashion. So, you know, very much like plug and play sort of thing. So it is very modular. It has a very simple core. So I'll show you the architecture works in the following way. So you have a very, very basic core. Actually, this diagram makes it look more complicated than it is, but it has a very simple core that has a service. It's got a service registry, and users can command line arguments or through other methods, they can activate additional modules to MEV Plus. So MEV Plus has a core, and it will interact with the clients in the same way that it has done before with the Builder API. That doesn't change. But what you can do with that around is completely up to the users. So what we have is we're not saying you need to use there's like one application that's going to. There's not going to be one thing in particular that benefits validators. We're saying we'll create such a proxy software in such a way that anybody in the community can create their own services, whether it be on-chain, off-chain. Anyone can write a plugin. That's the idea. And you can subscribe to the services that you want. So whether it's, we'll get into that in a bit, actually. So a bit more sort of on the plugins, so and on the architecture. So you have this MEV Plus core, and MEV Plus will basically emit standard events. Like I said, Builder API is very standard, but plugins that the user optionally enables or can enable in an automated way, they can sort of communicate with each other via event-based logic. So you just, via the core, whatever service is registered gets notified, and each service can decide whether or not they're interested in listening to an event. So for example, in this diagram, I've got a module that's talking to a Flashbot relayer, no problem at all, and that module can emit events through the core to other plugins. So that might be, a logger might pick that up and say, okay, well, we're just going to log and and push that into, you can push it into an elk stack or whatever you want to push it into. That's fine. Or you can build an analytics module. It's really sort of like up to community. It's very like I said, it's very plug and play, and anyone can spin up a plugin. So how do you do that? So this is a Golang service interface. Very straightforward. You need to handle an event. You need to respond to a start command that's triggered during service discovery, and you just need some kind of identifier. Outside of that, your logic is your logic, and the core it's just simply event management, and services react and perform actions on the basis of that. So you can have all kinds of innovations around this proxy software, and we want to build it in such a way. I think I skipped over one of the details in one of the slides, which talks about building it in a similar way to the way clients are built. So Ethereum clients, whether it's execution layer or consensus layer, they're built to an open specification. Everybody, contributes to the specification, and then you have n number of implementations in whatever language you prefer. With JavaScript, Rust, it doesn't really matter. So you build it to an open specification, and you build more resiliency for the network. But with the modularity and the ability to plug in additional modules for connecting to on-chain services, off-chain services, you can have signers, MPC networks, you can have anything plugged in here. It really has no limitations associated with it. And it's designed to be non-blocking and stuff like that, so services can't grieve other services. If you need to proxy into a validator and the user has agreed to opt into a service, everything's opt-in, you're good to go. And validators can sort of have this like low configuration, very much like they do now, but whilst not restricting themselves to certain services. So we can imagine like many applications being built around such an architecture. So what I want to do is give sort of Matt the mic back to talk about sort of current state of play with MEV transactions.
Yeah, this is done by Stefan on his Frontier. So it's basically give that very high level. A lot of things are involved in it. We don't see it. But what we see now, it's the MEV part is this, right? It's all missing. But we want to get included all these parties. We need to have toolings around it. How do we get this kind of intents and emits events and the software proxy? So you can think it like MEV Plus is kind of MEV Boost, but it's just like more integrated for doing additional logics into it. You can build MPCs and other stuff. But how does this actually work? The PoN Connect is the one that is actually make things possible with the infrastructure. So the PoN infrastructure is coming full circle for an intent-centric architecture. You can hire this transported layer that Andreas was mentioning in the last, and you can have this kind of a mini pools that will be, let's say, a Lido operator sets or Coinbase operator sets or some sort of builders. You want to sign it, and they can collect the money from there for whatever the transaction they performed in the past. They give the proof, and that's doing. One thing that we need to take care here is it's completely RPC free. So it's not really like the hooks that you see that you just give this to my RPC, we will protect you. There's no concept here. It's very agnostic tooling. And it's just smart contracts, just so you can collect the money later, so you can have the value. In an auction, the welfare is a very important matter, so you can actually get that money in later on. It also gives you multiple benefits. It's closely integrated with the validator score, so you can actually make programmatic decisions on the smart contracts to assign certain things like it's only going to go for certain, when you do that pools, a validator has a less effective balance will not get that money. So he needs to claim the money, he will prove that's the active balance. So not the active balance, effective balance. That's what basically, very important in the proposing role. So all these things can happen. It's kind of a diagram that what you're seeing here is like you have one SLA where you say that a protocol, Uniswap or anything, or liquidation services, and you can say that any transactions can be directed towards a set of actors off-chain. And then you can further give this kind of an attributes that set of actors, saying that as mini pools 1, 2, 3, and they will get that money from later, so they know it. They will listen. It's like a topics. They listen and they will come and they do the job, and if they've done the job, and they will collect the money. So how does the pre-block and post-block, we just mentioned how the PoN Connect works, is like the user or the protocol just create the intents, and it just could be anything, right? Could be the DAO rules or protocols, whatever that you want to enforce it. And it goes into this kind of NuGet plus builder, and this is like a full circle coming in like side execution, but you can also do without the get. You just want to get a simple intent like a swap and get it done. That can be done. But with the Get Plus, you can actually have much more faster execution because you're keeping all the state in that execution data block. But this is only possible after the Cancun update, by the way. So that's 4844 is needed. The post-block construction is like the payout pool, the smart contracts deployed for the PoN base infrastructure. You can plug in the SLAs and SLA pools, and then the relayers and all the off-chain connectors are taken by the transaction, including the block or in the state of the Get Plus, and then they can collect the money later. That's pretty much it about the PoN Connect. Again, this is something that we're releasing later on. Thank you.